Yeah, I know it's hard to remember the people we used to be. It's even harder to
LND 135 is a two-player local fighting game, similar to games like Street Fighter or Mortal Kombat. The creative freedom that the team got is what appealed to me with the game. Being able to design and create our own unique characters was very exciting. In the first session, the leader of the project split the studio up into teams which could be further specialised. In general, there was a management, art, programming and source control team. I chose to be in the source control team as I already had experience working in Git and Unreal in a team. The source control team was made of myself and Matthew Glanville. I was also in the programming team. In the first week, I created the Git repository and added a blank Unreal project. Me and Matt then worked on adding everyone to the repository and setting up the branches. Here is the repo's branch hierarchy. For the next week, I prepared a presentation which will be used as a reference for how to use Git, and I presented it at the start of the first lesson after the planning phase of the project. Here are the main points the presentation covered. This was a shared document with Matt, who also contributed by adding his own slides. Here's how the branches were used. The art team should be on the art assets branch, and the programmers should be on the branch named after them. They should never switch branch, and if they find themselves in the wrong branch, then they should switch back to their branch straight away, leaving their changes behind if prompted. Unreal's diff tool can compare blueprints, and this was quite useful in the project when resolving conflicts. Imagine you have a conflicting blueprint between branch A and branch B. We could get both versions of the file into Unreal and use the diff tool to compare them. While this is useful, it's not perfect. It takes a long time to do, and especially for each conflict in a team as large as ours. So the rule of thumb for programmers was to avoid conflicts like the plague. The most common way we resolved the conflict was just keeping or discarding the changed file after talking with the people responsible for the conflict. Each team member was assigned to a branch. A branch is their own version of the project, so they can push to that branch as much as they want, and no one else should change it. Every week there'll be a merge to update everyone's versions of the project. The way that we push to GitHub is to first connect Unreal to the Git source control, then press the submit content button in Unreal and give the commit description. Then you can push in GitHub. So we always commit in Unreal and push in GitHub. I also showed what I call the danger zone. I said no one should ever commit in Git desktop and pretend that that sidebar doesn't even exist. This information was correct, and by people following this advice, I believe issues were avoided and people were able to push their changes to the project. However, I did find that there was a time to use the commit in Git desktop, and that was when importing a content pack. The solution here was to have an up-to-date remote and add the feature pack and then commit in Git and then carry on committing in Unreal as usual. Here's the final advice that was given at the end of the presentation. A merge was done every Wednesday at the start of the lesson. Doing it in person was advantageous, as it meant that if there were any conflicts, we could go and get the people responsible for the conflict and talk with them on how to resolve this conflict. As mentioned previously, this oftentimes meant that one version of the file would be discarded. However, because we were in person, the most up-to-date version of the file was kept, meaning progress was rarely lost, and even when it was, at least Orf was aware of it. The way the merge was performed was to merge each programmer branch into the programming branch and resolve any conflicts, then merge the art into the programming branch, and if the programming branch works, then we can merge it into the main branch. Then we would redistribute this new project by merging the main branch back out to every other branch. We also set up branch protection rules on the main branch, this one being that any merges onto the main branch would require myself's and Matt's approval. I also voiced my opinions on components and event dispatchers, which was, use them. Components make conflicts super easy to resolve and minimises the chance of me deleting someone else's work. If a programmer creates a component and attaches it to a blueprint that another programmer is working on, the only conflict is that the component has been attached, so we can discard the component being attached and attach it after the merge. No work has been lost, and minimal work has to be repeated. It also saves the source control team a lot of time and effort. This is a much better way than the alternative, which is two programmers editing the same blueprint and then having to find a way to merge their work together manually, which takes a lot of time and effort. Event dispatchers are also great as it reduces dependencies between blueprints. The less dependencies there are, the more flexible the code is, which is very important in a large team. This presentation was made available for the studio in the Source Control public channel. Every lesson, me and Matt would merge the project, solving any conflicts or errors in the process, and redistribute the new working project. I would also be kept very busy moving around the class helping to fix source control issues on other people's computers. During these lessons I would communicate with the Scrum leader Bryce and project lead Agnes on the progress of the merge, and they would also communicate with me, tasking me with helping people in the class, which I would often do straight away, if not as soon as I'm available. Outside the lessons I did some programming, as within role of programmer I was given tasks to complete and asked for tasks to complete. First I made a round manager which waits for a player to die or for the round timer to run out. When the timer runs out, the round manager will find what player has the most health and increment their score. It will then check if either of the players have enough points to win. When a player dies, the round manager will get the index of the other player as they're the one who won the round, and increment their score and then check if any of the players have won. The game would be the first of 3 rounds. Then I made the player dodge, which speeds up the player's top speed and acceleration for 0.1 seconds before resetting it to normal. I started work on player health components, however I only did the bits that would be needed to interact with the round manager. I made an ability mockup for shooting. I also edited code to make the movement go only left and right. I created the gravity grenade and gravity grenade ability, along with the sound effect and particle effects for the ability. Apart from the GitHub work, this was my
pièce de résistance
for the project. The ability was made of a component for the ability and a blueprint for the grenade. At this stage we were split into 2-man teams, with each team making their own character, with the plan to combine features made by all teams into the characters at the end. This way we didn't have to worry about if someone else is working on the same feature, we just got it done, and hoped that it would show up in the final build. And while that sounds like a waste of time, all the programs became so much more productive after this idea was put in place. But because of this eventual combining of the characters, I had to make sure the component could simply be attached to any character and work. The gravity grenade component would simply spawn the gravity grenade and check which direction the player character is facing, and would apply a physics impulse to throw the grenade in the desired direction. I made the sound for the explosion in Audacity. I did this by layering and combining many different sounds until I got a result I was satisfied with. I also made particle effects following this tutorial. Particle effects are for the grenade explosion and black hole being active. I also followed this tutorial to make a shader for the black hole. The gravity grenade's visuals would work by playing the grenade sound as soon as it was spawned, waiting 3.2 seconds after spawning in, and then exploding. To explode, the grenade case mesh is hidden and the black hole mesh is revealed and quickly scaled from 0 to its full size. Then the explosion and ongoing particle effects are activated, and after a short time the explosion effect is deactivated. Then after 3 seconds of being active, the black hole is shrunk down, the remaining particle effect is deactivated and the actor is destroyed. With the visuals of the grenade explained, I would also like to explain the functionality of the black hole. Once the grenade has exploded, the black hole will start pulling both players in. It does this by getting the vector from the player to the black hole, normalising this vector and multiplying it by some strength value. Some extra features of the black hole which I like and believe make interesting game mechanics are that it affects the enemy and the player that threw it. Its influence drops off with range, meaning player 1 can throw the grenade at player 2. Player 2 will be locked in place from the black hole, but player 1 won't be influenced by it. When player 1 is ready, they can move towards the black hole, be pulled in and hopefully deal a devastating blow to the enemy. As well as the force dropping off with distance, the influence of the black hole drops off with time too. This is done using a float timeline when the grenade is spawned, which decreases the influence using this graph. Finally, I swapped out the grenade mesh for an alien grenade mesh that Bryce created. I had very good communication throughout the module. I was active in lessons and was active in the studio Discord. I would use the source control public channel to make people aware of the resources or when a merge was going to happen or any issues people needed to speak with. The other source control channel was used to discuss issues and put progress of a merge. I posted what work I'd done and progress in the general chat. I used the help request channel to help people remotely who needed GitHub support. I was also active in the other channels, giving words of encouragement and seeing other people's awesome work. I also used the programmer chat to give advice to the programmers. When programming, I was careful to make sure to keep my code clean and follow the programming standards that Bryce had created. Me and Bryce had a few meetings where we discussed the standards of my blueprints. They were often up to par with the standards document. If they weren't, then Bryce would give me helpful feedback on how to amend them. Before the last night of the project, I noticed that the bandwidth quota for the Git LFS was nearly full. I notified the management team and joined in on a meeting on how to resolve this issue. It was decided that me and Matt would do our part of the merge on Tuesday night and quickly resolve conflicts in the Wednesday lesson so that Agnes could hold a studio-wide meeting where any unneeded assets were deleted from the project, reducing the total size of the project and how much bandwidth it uses to clone. I've had a great time working as part of the game studio. I believe I've learned a lot of skills which I'll take forwards. Thank you for watching.